Students, how to solve numericals or problems in magnetic effect of current. You know, in Biot-Savart law, your formula is dB is equal to some constant, that is your mu naught by 4 pi I dl cross r by r cube. This is the formula for magnetic field at a distance r for a small element dl carrying current I. Suppose this is any element, it carries current I, and for this small element dl you find magnetic field here and you join this is your r vector. This is the small element, very small element, and from this element this distance is r vector. R vector is nothing but the position vector of what? Position vector of this point P where magnetic field is a dB. And what is this? If you explain dl cross r, I mean dl to r rotation. So how to know the direction? The direction of magnetic field can be known either by cross product rule or the Maxwell's right hand screw rule. How? If dl cross r is clockwise, magnetic field is inward. How? You see, suppose this is a small element, in this direction it carries current I. Here is a point, so you join this is r vector. This is what dl, since current is in this direction, that's why dl is in this direction. So dl to r, dl cross r, I mean rotation from dl to r. If this is clockwise, then magnetic field is inward. I mean here magnetic field will be inward. This is the symbol for inward magnetic field. Either you write inward or you just give that symbol. Similarly, students, if the point is here, left side of this, so you join this is r vector, dl cross r, dl to r, dl cross r means dl to r. Since this is anti-clockwise, your magnetic field is outward. I mean, you know the direction of magnetic field for a small element dl. If dl to r is clockwise, then magnetic field is inward. If dl cross r is anti-clockwise, magnetic field is outward. And this Biot-Savart law is applied to a circular conductor as well as a straight conductor. Suppose this is a circular conductor, it carries current I. So how to find out magnetic field at this point O? The radius of the circle is r. So how to find out? You consider a small element dl, because Biot-Savart law is valid for this small element. So this dl is like that, and you join this and this angle is what? 90 degree. Always radius is perpendicular to this tangent or small element dl. So how much magnetic field is obtained at this point due to this small element? This is nothing but dB is equal to constant mu naught by 4 pi I dl sin 90 degree divided by r square. This is the expression for Bayes-Savart law. Of course, I put 90 degree for angle theta, and that gives you how much? This is mu naught by 4 pi I dl by r square. Sin 90 is 1. For this dl, you get magnetic field at O, that is dB. If you take such small element like that, here is a small element, here is a small element, here is a small element, like this. So what you have to do? So for this element, magnetic field is that. For the entire circle, you have to integrate. So if you integrate, you will get B. That will be mu naught by 4 pi I by r square constant. This is integration of dl because I is constant. Current I. R, this is radius. Of course, this is a small radius. Anything you take, either capital R, small r, no r. So after integration, this is nothing but 2 pi r. So that is what? Mu naught I by 4 pi r square into 2 pi r. This gives you mu naught I divided by 2r. So magnetic field, what you get? Here you check it, you get, that is B is equal to mu naught I by 4 pi r square integration of dl. After integration you will get mu naught I by 4 pi r square into 2 pi r, and after solving you will get mu naught I by 2r. So this is what your magnetic field at the center O due to the whole conductor. What is the direction? Direction of the magnetic field is very easy. How to remember? If current is clockwise, magnetic field is inward. At this point, this is inward magnetic field. If current is anti-clockwise, magnetic field is outward. For outward, this is dot symbol. So very easy to remember. In a circular conductor, if current is clockwise, this is inward magnetic field. If current is anti-clockwise, this is outward magnetic field. So students, you get the formula for a circular current carrying conductor as how much? This is B is equal to mu naught I by 2r. This can be written as mu naught I by 4 pi r into 2 pi. Why I write in this format? Because for a circle, this angle is 2 pi. That's why I write in this form, 2 pi. But in a general form, I can write in general B is equal to mu naught I by 4 pi r into theta. This is theta. If it is a full circle, theta is 2 pi. If it is a semicircle, theta is pi. Like that. So for full 2 pi, for semicircle like this. If this is a semicircle, then angle is what? That is your pi. So in place of theta, you can put pi. So you know magnetic field for a circular or for a arc. Now, how to solve problems for it? Suppose here is a circle. Here is another circle having same center O. This radius is R1. This radius is R2. This carries current I1. This carries current I2. I mean, what does it mean? It means a circle is inside another one. One circle is inside another one. We say concentric circles having same center O. So what is the net magnetic field at this point? For inner circle, your magnetic field is mu naught I1 by, what is this, 2R1. But what is the direction? Since it is clockwise, magnetic field is inward. Similarly, B2 is equal to mu naught I2 by 2R2. Since it is anti-clockwise, current is anti-clockwise, that's why outward magnetic field. So one is inward magnetic field, another is outward magnetic field. I mean both are in same direction. At this center, one is towards the board or inward, another is outward, means towards you. So net magnetic field will be subtraction, either B1 minus B2 or B2 minus B1. Why? Because you don't know which one is greater. If B1 is greater, you have to take B1 minus B2 with direction inward, otherwise take direction outward. So this is one type of solution to solve magnetic field for concentric circles. If we consider like this, suppose this is an arc. Here is a straight conductor like this. This is straight conductor. This is O. This is R is the radius of the circular arc. The arc is your, suppose SC is the arc. O is the center and this angle is suppose pi by 3. Or you say 60 degree. So in that case, how to find out magnetic field for this system? For SC, your magnetic field is mu naught. Suppose the current is I. So mu naught I by 4 pi r into theta. Theta means what? Pi by 3, because this arc makes an angle pi by 3 at center O. That's why in place of theta, I put pi by 3 and direction is inward. Why? The current is in clockwise. The current is in clockwise direction. That's why magnetic field is inward. But what about this straight conductor? One can say, sir, if these are the straight conductor, what is the magnetic field at O if they carry current? 0. B is 0 for this conductor and that conductor. Why? You just see the Bhatt-Savart law. This is the small element dl. This point is r. This angle is theta. Since theta is the angle between this r and dl, so if theta is 0, matlab theta is 0 means point lies on the axis. Here is the point. Here is the point. If point lies on the axis, then theta is 0. Theta 0 means sine 0 is equal to 0. That's why magnetic field on this point is 0. So for this conductor, magnetic field is 0 at this point. Only exists for this arc, and this is the answer. So if we make other type of problem like this, Current is like this. If the current is in this direction, suppose this current is I, suppose this is your R1, or you say this is your R2, or you say this is your R3, or you say this is your R4, this is R4, this is R3, this is R2, this is R1. And suppose this angle is pi by 6, 30 degree. These arcs makes 30 degree at the center of pi by 6, 30 degree. So what is the magnetic field? Net magnetic field. For this arc, your magnetic field, suppose I take B4 is equal to how much? Mu naught I by 4 pi R4 into theta matlab pi by 6, that is inward direction. Why this is inward? Because current is clockwise, that's why inward. Similar students, for this arc B3 is equal to mu naught I by 4 pi R3 into pi by 6 outward. Angle is theta is what? Pi by 6. Pi by 6 is for all. But in this case, since it is anti-clockwise, so this is outward direction, that is for B3. Similarly, B2 is mu naught I by 4 pi R2 pi by 6 clockwise. B1 is equal to mu naught I by 4 pi R1 pi by 6 anti-clockwise. For the four arcs, you find out the direction like this: B1, B2, B3, B4. Two clockwise, two anti-clockwise direction. Okay? But what about this straight conductor? For this straight conductor, these are 0. For this straight conductor, these are your 0, because for this magnetic field is 0, for that magnetic field is 0, for that magnetic field is 0, for that magnetic field is 0. So what is the net magnetic field for this? This will be added with this because two are inward. This will be added with this because two are outward. Then net magnetic field will be B is equal to, either you take, what is the answer? The answer will be, that is B1 plus B3 minus B2 plus B4. B1 plus B3 minus B2 plus B4. If you take, then that will be outward direction. If you take B2 plus B4 minus B1 plus B3, that will be inward direction. So in this way you can solve problems. Okay.